Hello everyone, this is Professor Gant and I'm recording this quiz 2 review for you in my absence. Sorry I can't be there, but I wanted to make sure that you had some type of instruction so that you can kind of understand my thought process as to how to do some of these problems. So I'm going to go through these. I'm going to do the best that I can to try to teach you some of the basic concepts while at the same time trying to make this video not 3 hours long. Okay, so I'll go ahead and get started on this first problem. The first thing that we want to do here is just graph this linear equation by using the slope and the y-intercept. And so before we begin here, I want to make sure that we understand a few things. First, when we talk about the equation of a line, there's actually three forms of an equation of a line. One form is the form that you're familiar with the most probably, which is what we call the slope-intercept form. And we call it that because this m right here represents the number for the slope, and this b right here is a variable that represents the y-intercept. So what the slope is how the line inclines. So if a slope is positive, then it means it goes up from left to right. If a slope is negative, then it goes down from left to right. If the slope is 0, then this is a flat line, or we call it a horizontal line. And if the slope is what we call undefined, or sometimes we say that it's infinite, then that is a vertical line. Okay. Now, for just a general line here, I'll just make up another one to make it really quick. Here, if we were going to graph the line 2x minus 3, then this 2 being positive tells us that our line is going to go up from left to right, and this minus 3 tells me that the graph is going to cross the y-axis at the point 0, negative 3. So using that right here, it would look like this. I would have the point 0, negative 1, negative 2, negative 3 right here, and my graph would kind of look like this. Okay. Now, to make it more precise, what's going to happen here is that we're going to use the interpretation of the slope, and one interpretation of the slope is going to be rise over run. Okay. Rise meaning do you go up or down? And run meaning do you go to the left or right? Okay. So in this case, to say that our slope is 2 over 1 means that we rise up or move up in the y direction 2 units, and we go to the right 1 unit. Okay. So looking back here, if I wanted to graph this line, not the one that we're going to work on here, but if we're going to graph this line, then this would be at the point 0, negative 3. And then from there, this tells me from this point to go up 2 units, 1, 2, and then to the right 1. And then I pick another point. And I can do the same thing again by going up another 2 units, 1, 2, and then to the right 1 again. Okay. And then after that, I can just draw the line that goes through those points. And that's how we can use the information from the equation of a line to draw a line without us having to do a whole lot of work. Okay. So now that I've said that, we now sort of have a way of looking at this problem. Okay. So I'm going to go ahead and erase all of this and now do this problem. All right. So now that we kind of know what's going on here, let's go ahead and do this problem. So from this form, we have the slope is going to be a negative 1/2, and we know that the y-intercept is going to be at the point 0, 2. Okay. And so here we realize that we'll start at the point 0, negative 2, which would be right here on our graph. And of course, 0 meaning that we go no units in the x direction or horizontal direction, and negative 2 means we go down 2 in the y direction. For the slope being a negative 1/2, What that means here is that I can either do one of two things. I can interpret it this way, putting a negative on top, meaning that I go down 1 unit and to the right 2 units from a known point on the graph. And of course, my known point here is the point 0, -2. Alternatively, I could also go put the negative in the denominator, and I can go up 1 unit and to the left 2 units and find another point that will still be on that same line. So I'm going to do one from each to show you that no matter whether I put the negative in the numerator or if I put it in the denominator, that I still end up with points that are on the same line. So here I know that going down 1 unit from this known point, 0, -2, go down 1 unit and to the right 2 would put me at this point right here. If I use this interpretation from the point 0, -2, I can go up 1 unit and to the right 2, and that will put me at this point right here. And then, of course, I could take my line and draw it through those points. And so that's how I would do this first problem. Just to round out this discussion, I did say that this was one form of an equation of a line that we call the slope-intercept form. Okay. Now we have two other forms. One is called the general form, which looks like this, where we have some number times x plus another number times y equals a number by itself. And we also have what's called the point slope form of an equation of a line. So this is point slope. And this is the standard form or general form. All three of these forms have their advantages and disadvantages. Main thing for this one, of course, we can see what the graph looks like real easy by the slope and the y-intercept. For this one, there's two purposes for it. One is that I can easily find x and y-intercepts when my line is in this form, and we'll see that later. And in this form, we'll also use this to be able to find the equation of a line whenever I have information like I know what the slope of a line is, as well as some point that's on its graph. All right, so let's move on to number 2. So you can see for number 2, we have an equation of a line, but now it is in standard or general form. And so you notice how this says graph the linear equation by finding and plotting its intercepts. So what we mean by that is find its x-intercept as well as its y-intercept. By definition, an x-intercept is you have some value for x and your y value is 0. It is a place where the graph crosses the x-axis. Y-intercept, by definition, lets x equal 0, and then we have some number for y. And it is the place where your graph crosses the y-axis. And this will be true whether we're talking about a line, a parabola, or anything else. Okay. So in short, how we can use this form of the equation of a line to quickly find out what's going on here. Here we know that for the x-intercept, I have to let y equal 0, right? So if I take this equation here and let y equal 0, then it looks like this. And then of course 2 times 0 is just 0, and negative x plus 0 is just minus x. And so from here we can divide both sides by a -1 to get x by itself, and we see that x is -6. So when y is 0, x is -6. So that would be my x-intercept point on my graph. So that would be right here if I was to plot. For my y-intercept, it would be the same thing. But instead of letting y equal 0, now I let x equal 0. So if that's the case, then I would have negative and then 0 plus 2, So just 2y. It's too long there, okay? So 2y equals 6. And of course, all this is just 0, and 0 plus 2y is 2y equals 6. We divide both sides by 2, and we get 3. So our y-intercept point on the graph is going to be the point 0, 3. So that would be starting from the origin. We go no direction in the x direction, but go 3 up in the y direction. And so we have our 2 points. As long as we have 2 points, we can draw a line. And so that is what our line would look like. Okay. Now, we kind of did this the long way here. If I did this the short way, I could kind of make what we call a T-chart and say, hey, I know for one of these points, x has to be 0. For another one, y has to be 0. And if x has to be 0 here, then that means this term would basically go away. And all I have is 2y is equal to 6. And of course, 2 times 3 is 6. So that'll let me know that that point is 0, 3. Similarly, if I know that y has to be 0, then that means this whole term goes away. And now all I have is a negative x is equal to 6, which means that when I either divide or multiply by -1, negative 6 is equal to x. So I could do the same thing as I did here by just noting that since I have this equation in standard form, whenever I plug in 0 for either x or y, it just makes that term go away. Okay. All right, so let's move on to the next question. All right, so again, we're being asked to find the x and y intercepts and to actually plot those and graph the line based upon what we see here. So the difference in between question 2 and question 3 is that for question 2, we just need you to graph it, whereas for question 3, I'm telling you in order to get full credit, you have to write the x and y intercept in its point or ordered pair form. Okay, so here notice that our equation is in slope-intercept form. So we're going to do it the traditional way. For the x-intercept, we'll let y equal 0. And if we do that, then 0 is equal to 3x plus 6. We'll subtract 6 from both sides. And then from here, divide both sides by 3 in order to get a -2. So that means when y is 0, x is -2. And so our y-intercept is -2, 0. For our y-intercept, we know we have to let x equal 0. And of course, here, by definition, since this is in slope-intercept form, if x is 0, that makes this whole term go away. And whatever that number is just what the number for the y-intercept is. So we could look at it and tell that this point is 0, 6. But if you couldn't, of course, what we could do is again just let x equal 0. You see that 3 times 0 is 0, and 0 plus 6 is 6. So now that we have these 2 points, we just graph them and then draw a line through it. So the point -2, 0, start at the origin, go 2 units to the left, no units up or down. For the y-intercept, no units to the left or right, but we go 6 units up. And then from there, we just draw a line through those 2 points. And that is what our line is going to look like. All right, so for our next question, we're asked to find or draw the line of a particular function here, or basically draw this line by having 3 given x values, and we want to find the corresponding y values, plot them all, and then draw the line through those 3 points. Okay. So in this case, notice that this is in general form again, or standard form. And so we could easily find out what the x and y intercepts are. But the purpose of this example is to test to see if you can actually plug in a value for x and solve for y. Okay, so for this first one here, when x is -4, we want to find out what y is. So 3 times -4 is a -12. And then we want to add 12 to both sides because our goal here is to get y by itself. -12 plus 12 cancels to 0. So we just have 4y is equal to 12. We divide both sides by 4 and we get y is equal to 3. So when x is -4, y is 3. Similarly, if we let x equal 0 plus 4y equals 0, then of course this is 0. So 0 plus 4y is 4y equals 0. Divide both sides by 4 and we see that y is just 0. So that would be here at the origin. And so we'll go ahead and plot these points now as well. So we got -4, 3, which is here. Go 4 to the left and then up 3. And we also have the point 0, 0, which is right here. Now, getting this last one, we'll let x equal 4 plus 4y equals 0. And of course, this is 12. So 12 plus 4y is equal to 0. Subtract 12 from both sides because we're trying to get y by itself. The 12 and -12 cancels to 0. And then we divide both sides by 4 and we see we get -3. So when x is +4, y is -3. So coming from the center, 4 to the right, down 3. And from here, we just draw a line through all 3 points. And that is what our line would look like. Okay. Now for these next set of questions, 5, 6, 7, and 8, there are specific things that we have to know about the equation of a line to be able to do these. In particular, 5 and 6 are not hard. You just have to know what to do. And to know what to do, you have to know what the words mean. So in general, whenever we say we have a vertical line always has x values in common. So for instance, if I had 2 points here, and let's say this was the line x equals 2, then this could be the point 2, 1. This could be the point 2, -5. Okay. The one thing that is the same is that the x coordinate is the same, and that's always true for vertical lines. Similarly, for a horizontal line, we know that horizontal line, the y coordinates are the same. So if this was the line y equals -3, then this could be the point 1, -3, and this could be the point 3, -3. Okay. So with horizontal lines, always y equals whatever the y value is. For vertical lines, x equals whatever the x coordinate is. So in general, if we're told that we have a vertical line and it goes through some point AB, then of course we will, well, let me not use A and B here. I use that up there. I'll use X and Y. So a simple way I remember this is to say that here, X always goes with vertical, Y always goes with horizontal. So it says vertical line, then I know it's going to be X equals whatever this number is. If it says horizontal line, it's going to be Y equals whatever the Y coordinate is. Okay. And I could also rephrase these. Instead of saying vertical line, I could also say my slope is infinite or my slope is undefined. Okay. All those things mean the same thing because we know that for a vertical line, the slope is infinite or undefined. Okay. If this says that my slope was 0 for a line, then of course I know that they're still talking about a horizontal line. Okay, so regardless of whether you get questions that are worded this way, vertical line through this point, or if they say line going through this point with a slope that is undefined or slope that is infinite, you know that they're talking about a vertical line. And of course, if they mention anything about the slope being 0 or it's a horizontal line, it means the same thing. All right, so now that we know that, let's go ahead and do these two problems quickly. All right, so for the vertical line, we know that vertical line deals with x values here. So we know that we're talking about this particular coordinate. So the equation for that would just be x is equal to -7. And of course, that makes sense because for a vertical line, doesn't matter what y is, x is always -7. For here, we just said horizontal line, so it's talking about the y coordinate. So equation for this would be y equals 0. Because it doesn't matter what x is, y always has to be 0. And for these questions, it really is just that simple. So let's move on to question 7 and 8. All right, so for question 7 and 8, we're testing the concept of you knowing what a parallel line is versus a perpendicular line is to another. So in short, if I have a line that is parallel to each other, then the one thing that I know about both of these lines is that the slope of those lines are the same. And parallel just means that they don't cross. And the only time lines do not cross is when they have the same slope. Perpendicular lines cross, but they cross in such a way to where they cross at a 90-degree angle. And so the relationship in between these type of lines is that one line is always the one of the line slope is always the negative reciprocal of the other. Okay, so what I mean by that, if I had my original line, if the slope of that line was 2, and I wanted to find out what is the slope of the perpendicular line, that would just be -1/2. Similarly, if I had the slope of an original line, which let's say -1/5, then of course the slope of the perpendicular line would be a +5, because of course the negative reciprocal means we take the opposite sign of whatever this number is and then flip that fraction. In this case, the reason why it ends up being a -1/2 is because 2 is the same as 2/1. We take the opposite of 2/1, which is -2/1, and then flip the fraction. Okay. So with that being said, whenever we answer these questions here, it'll be relatively easy to do if we remember these concepts. All right, so for number 7, you see we want to know a line. We want a line that is parallel to y equals -10 that goes through this point. Okay, so I'm going to draw what's going on for this so that we can conceptually see why I'm going to answer what I answer. So let's say draw XY plane here, and the point -7, 8, let's say it will be somewhere around here. Okay, just kind of making this up. And of course, if I want a line parallel to y equals -10, we know that y equals -10 is going to be a horizontal line. I want it to be parallel to this, so the only way it can be parallel to it is to also be horizontal. So that means I would have to draw this line through here, for this point, okay? And so one of the things that you know about any point on a horizontal line, all the y coordinates are the same. So here, the answer to this, of course, would just be y equals 8. And if you think about it, here, again, if y is going to be, y equals -10 is going to be a horizontal line, then the slope of that line is 0. So that means if I want the corresponding line I'm trying to find to be parallel, it must also have a slope of 0. And of course, we see that y equals -8 does indeed have a slope of 0 as well, because it's a flat line. Okay. Now, for perpendicular, a line, we want to find a line that's perpendicular to x equals 4, but goes through this point. Okay. So perpendicular means it intersects at a 90-degree angle. Looking at this equation, we know that this represents a vertical line. Okay. So we have a vertical line here for x equals 4, and we wanted to go through this point but be perpendicular. If I take a vertical line and intersect it at a 90-degree angle, that's going to be intersected with a line that is horizontal. Okay, so here we know just by the fact that this has to be horizontal, then we know that it's going to talk about the y coordinate here. So the equation would be y equals 12. Okay, if I draw that out, like how I did the one above, it'll look like this. So we have a line x equals 4, which looks like this. And I have the point 112. Let's say if y is equal to 1 here, then this is 12, this point, and we want it to be perpendicular. So perpendicular means that it's going to intersect at a 90-degree angle, which is going to look like this. Okay, notice that that line here is horizontal and the point 112 is here. So the one thing that is the same about every point that is on this horizontal line is that its y coordinate is 12. And so you can see why for this line being perpendicular, it's y equals 12. For this one, for it to be parallel, it's y equals 8. And also, just to make sure that we're clear here, we know that for x equals 4, the slope of that line is going to be undefined or infinite. Okay, mess that up. For the slope of y equals 12, we know that since it's horizontal, the slope of that's going to be 0. And of course, these are pretty much negative reciprocals of each other, because whenever we say we have a slope that's infinite, what we really mean is that we have a slope of some number divided by 0. And of course, if I was to flip 1 over 0, I would get 0 over 1, which equals 0. So that's why for lines that are perpendicular to each other, we have to take the negative reciprocal. And in this case, trying to do the negative reciprocal of -0 divided by 1, that's just still going to be 0, since 0 is neither positive nor negative. All right, so let's jump to the next set of questions. All right, so for questions 9 and 10, what we're asked to do is actually find the equation of the line. And we want to write the equation in slope-intercept form in this case. So in other words, we want to use the information that's given to us here and end up writing a line in this form. Okay. Well, one of the things that we know is that in order to find the equation of a line here, we either need the slope of a line in one point, or we need two different points. And the reason why in the case of when we just have 2 points, we need 2 of them, is so that we can actually calculate what the slope is. Because we know slope is equal to rise over run, which is also the same as y2 minus y1 over x2 minus x1. Okay, so knowing that, that's how we're going to start this off, by labeling this x1, y1, x2, y2. And of course, it does not matter if you label this point x1, y1 or this point x1, y1. It wouldn't matter. So if you name one of these x1, y1, then the other one has to be x2, y2. So what we're going to do here is go ahead and set up everything, and from that point find out the slope. And then I'm going to do this by using the slope-intercept form to be able to find the equation of the line, as well as I'm going to also do it using the point slope form. And you can pick whichever way resonates with you the best. All right, so I'm going to go ahead and erase this part here and then begin the problem. Okay, so if we look here, we know that our slope has to be equal to y2 minus y1 over x2 minus x1. And we just look and write. So y2 is negative 14 minus y1 is a negative 23. And you see how I did the parenthesis there to make sure that the negative 23 was separate from the subtraction sign, so that we know that subtract and negative is the same as addition. And we have 5 for x2 minus x1 is 8. And so now, again, like I said before, subtract and negative is the same as addition. And so now, whenever we do a negative 14 plus 23, that's the same as saying 23 minus 14. And of course, if we do the difference of that, that's going to end up being 9. So we have 9, and 5 minus 8 is going to be negative 3. So 9 divided by negative 3 is a negative 3. And that's what our slope would be. So now what we're going to do is, if we use slope-intercept form, if we want to find the equation of a line, we just write this form here, and we're going to use one of these 2 points. I'm going to use this one and just call this x, call that y. And for the slope of negative 3, we're going to plug that in for m. So if we do that, then of course we have negative 23 equals negative 3 times 8 plus b. And so the reason why we're plugging in all this information is so that we can find out our y-intercept. Once we have our slope and we have our number for the y-intercept, then we have everything we need to put it in this form here. So that's why we're solving for this. So we have negative 23 equals negative 24, because negative 3 times 8 is a negative 24. We add 24 to both sides. That cancels, and we just get b, and negative 23 plus 24 is a positive 1. So our equation of a line here is negative 3x plus 1. And this is how it looks if we do it in slope-intercept form. Now, if we use point-slope form to get the same answer, then we use this form of an equation of a line. And what we do is we plug in what y1 is, what m is, and what x1 is. And we just solve for y. So I'm going to use a different point for this one. I'm going to use a point 5, negative 14. So y minus negative 14 equals m is negative 3, x minus x1 is going to be 5. And again, don't want you to get confused here. I can use either one of these points I want, okay? I know right now I have this labeled as x2, y2, but I could have simply got rid of this and said, call this x1, y1, and call these two x2, y2. Doesn't matter. All the x1 and the y1 means is that I need to use the x coordinate and y coordinate from the same point, okay? Now, finishing this, we know that subtract a negative is the same as addition. So that'll be y plus 14. We distribute our negative 3 across. So it's negative 3x plus 15, because again, a negative times a negative is a positive. And then here we just solve for y. And we get y by itself by subtracting 14 from both sides. 14 minus 14 cancels to 0. And 15 minus 14 is a positive 1. And so you see we get the same answer no matter whether we use the slope-intercept form to find the equation of a line or we use the point-slope form. All right, so moving on to number 10. For this one, this problem is much, much easier than trying to do the one that we did above. And the reason for that is we can find an equation of a line given the slope and y-intercept. Here, we know that the slope-intercept form basically asks for that information. It has what is the slope, what is a y-intercept. So literally, if I use 3 for the slope and minus 6 for the y-intercept, what I'm going to have, 3 for the slope and negative 6 for the y-intercept, then literally what I'm going to have here is the following. Y equals, in place of m, put 3, x plus, in place of b, put minus 6. And that is the equation of the line. That's all there is to it. For question number 11, we're asked to take the slope and this point and write the equation in the form of ax plus by equals c, which is general form. Okay. So we'll start off by doing some of the same things here. Simple way to do this is we could take the point that we have, we can call this x1, y1, and take the slope and use the point slope form to be able to get this into a valid equation of a line, and then we're just going to rearrange it to make it look like this. So our y1 here is 5, our m is a negative 2/7, and our x1 is going to be 4. Okay. Now, to try to make the math a little bit easier here, what I'm going to do is I don't want to deal with this negative 2/7 and distribute it over to both terms here, because if I do that, then I have to deal with more fractions. I know that since this is negative 2/7 times x minus 4, one thing I could do is multiply both sides by the LCD of this particular fraction, which is 7, so I can clear out the fractions. And if I did that, it would look like this. So I would say, let's multiply 7 to both sides here. Let's also multiply 7 to both sides here. And when I do this, since this is multiplication here, this really just looks like this. So there's no need for me to have to distribute 7 to negative 2/7, 7 to x, and 7 to minus 4. No need to do that. Okay. So on this side here, I know that 7 is the same as 7 over 1, and this 7 and this 7 reduces to 1. So what I have left on the left side here is just this negative 2 times x minus 4. On the right side here, I do want to go ahead and distribute that because that's not going to be too hard to do. That'll be 7y minus 35, and again 7y minus 35. So coming here to finish up, we now want to distribute just the negative 2 here because that's easy to do. 7y minus 35 equals negative 2x plus 8. And so now we want to rewrite this to where we have some number times x plus another number times y equals some number. So to do that, I am going to add 2x to both sides, and 2x and negative 2x cancels to 0, and you just have 8 here. Since 7y and 2x and minus 35 are unlike terms, the best that we can do is just write all of them out. And then after that, since we want it in this form here, this c just represents a number by itself, so we need to add 35 to both sides. And if we cancel here, we'll get 2x plus 7y, and this will end up equaling 43. So this is our answer. All right, so for the next set of questions, what we're asked to do is to solve the compound inequality, graph the solution set, and then write the solution set in interval notation. And so for this, if you're unfamiliar with interval notation, one of the things that you should do that I highly recommend is watch the interval notation videos that I have available for you. But in short, whenever we have compound inequalities, we have two types. We have what we call conjunctions and disjunctions. 12 and 13 are the type that we call conjunctions, because what this really means is that we have two separate single inequality statements that are being what we call anded together, meaning that we want the overlap in between them. For example, for number 12, this is an abbreviated way of actually saying that 2x minus 1 is greater than or equal to 3, and at the same time, 2x minus 1 is less than or equal to 11. Okay, but since whenever we're able to take conjunctions and write them in an abbreviated form, it actually makes it easier to solve these types of inequalities if we write it the way that we have it here. Okay, so to solve an inequality, it's the same rules as we use to solve an equation. The only thing that's different is that instead of whenever we multiply or divide both sides by, or all sides of an inequality by a negative number, we end up having to flip the signs, okay? Or as we say, change the sense of the signs. So as long as we don't have that issue, everything is pretty much the same as solving equations. So here I want to get x by itself. So to do that, first thing I know I have to do is add 1 to all sides of my inequality. So 3 plus 1 is 4, less than or equal to negative 1 plus 1 is 0, and I just have 2x left, and 1 plus 1 is 2. So 11 plus 1 is 12. And so now, to get x by itself, we have to get rid of this 2, but the legal way to do that is to divide by 2. So we have to do it to all sides. So 4 divided by 2 is 2, 2x divided by x is x, and 12 divided by 2 is 6. So this is the inequality answer for this compound inequality. Basically, x has to be in between 2 and 6, including 2 and 6. If we write this answer in interval notation, it will look like this. And so the basic idea here is that whenever we have the less than or equal to or greater than or equal to signs, we use brackets in that place. Whenever we have, let's say, just less than or greater than, then we use parentheses. So for example, I'm going to erase this here. Let's say instead of having less than or equal to there, I just had less than. What would be different in this case is that now the interval notation would look like this. It would look like x equals bracket on the 2, but a parenthesis on the 6. And what this says is I want every x value from negative 2 to 6, including 2. Sorry, let me say that again. I want this x value is every number in between 2 and 6. And we're including 2, but excluding 6. Say it one more time. So this x value, this compound inequality here is saying that this x value is going to be all real numbers from 2 until you get to 6. And 2 is included in the set, but 6 is not included. So that's what that would look like if I didn't have a less than or equal to sign here and just had a less than. So, of course, I put that back in, and now that changed to make it look like that. So, there's 3 parts of this. One is to solve the compound inequality. That's this part. To write your solution set in interval notation is this. And then to graph it, all I'm going to do is come here. Let's pick 2, 3, 4, 5, 6. And we're going to put some brackets here, some brackets here. And we're going to color this in to say that our solution set represents all real numbers in between 2 and 6, including x equals 2 and x equals 6. All right, so moving on to our next example. Also a conjunction. Here we need to get x by itself, so we just divide all three sides by 5, and we get 4 is less than x, which is less than 6. And so all we're saying here is that x is in between 4 and 6, excluding 4 and excluding 6. And of course, we just learned whenever we exclude, we need parentheses. So we need a parenthesis on the 4 and the 6. And all this says here, when we have x equals 4 comma 6 in interval notation, which is what this is, this just says, again, that we include all x values that are strictly in between 4 and 6. So let's say if I allow this to be 4, and I allow that to be 6, then I would do parenthesis here, and shade in, to say that I'm including every number that is strictly in between 4 and 6. All right, so for this next one here, this is what is called a conjunction. Sorry, a disjunction. And the reason for that is the or. So whenever we have disjunctions, whenever we graph our solution sets, it looks something like we have a set of x values over here, but then we have a gap in between and we have another set of x values over here. That's valid. Now, the good thing about disjunctions is that when they're written properly, they have to be written as some single statement or another. So you kind of know what you're dealing with. Now, for this, if we want to get x by itself, solve this one, we'll divide both sides by a -3. And now remember, whenever we take an inequality and multiply or divide it by a negative number, we have to flip the sign. Okay? And of course, -3 divided by -3 reduces to 1, and -8 divided by a -3 is a +8/3. Okay? So we write our word or, and or means that I can pick from either here or here, and there's not anything to do with this one, so I just pick it as is. So we're saying that my x values either have to be greater than 8/3 or they have to be smaller than or equal to -18. So let's say I put a -18 here, +8/3 there. So for here, if I wanted to graph this, x being greater than 8/3, I would put parenthesis here and then just draw out everything going to infinity there. Okay, I'm going to make this look a little better. And for x being less than or equal to 18, of course, -18 is the upper bound. So you would have this, and it looks like that. And of course, for the interval notation, if you watch the videos, you know that the word or in set theory, when we talk about sets of things, uses the symbol U, which means union. Okay, so here, and we also know that with interval notation, we always go from smallest number to largest number. So in this case, the smallest number is really a concept, which is -infinity. And it keeps on going until we get to -18, and we put a bracket there. And instead of the word or, we do a union, and then we start again with parentheses at 8/3, and we keep on going to infinity. Okay? One of the things that we want to make sure that we remember is that with infinities, we always put parentheses on positive and negative infinities. The reason for that, brackets only are valid whenever you have a finite number that you can actually reach. Since infinity is a concept and not a number, we can't say that we can include something that we don't know how much it is. So in that instance, you want to make sure that anytime you have to write -infinity or positive infinity, you make sure you put parentheses by it. And also remember that whenever you're doing interval notation, it is always from smallest number to largest number, from left to right. Okay, and that's it kind of goes with the way that most people read. Now, of course, if your first language is something to where you read from right to left, then this may be an adjustment for you. Okay, but in this hemisphere, we read everything from left to right, and whenever we do interval notation, it's the same thing. We're looking from left to right to do it. All right, so let's move on to our next set of problems. All right, so for 15, 16, and 17, these are just the problems where I'm trying to test to see, can you solve linear equations of different types, okay? And so the goal here again is to get x by itself. And whenever we have equations that have fractions in them, if we don't want to deal with the fractions, what we'll do is multiply both sides of the equation by the LCD, which is the least common denominator. And of course, we may pick various times to do that, but we'll pick times where it's most convenient. So let's start with number 15. So for this one, we want to get x by itself here. So what we can do first off is just add 5 to both sides here, because we need to get this term by itself, which means we need to get rid of that one. So that cancels to 0, and 1/3 x is the same as x over 3 equals 1 plus 5 is 6. From here, we need to get x by itself. It is being divided by 3. So to get rid of this, we need to do the opposite operation, which is multiply. But with the equations, what we do to one side, we have to do to the other. So in this case, taking 3, which is the same as 3 over 1, and multiplying it times x over 3, we know that these 3's reduce to 1, and 1 times x is x, and 6 times 3 is 18, and that is our answer. So moving on to number 16, what we're going to do here is, before we can do anything, we need to take the understood 1 that is right here by the subtraction sign, because we know that if I'm writing, oops, messed that up real good. So if I am writing this portion here, I know that subtraction is the same as plus a negative, and in this case, plus -1 times what we have here, okay? And of course, we can distribute the -1 to both terms, but since we know that it's understood, we just imagine that this is a -1 and go ahead and distribute. So we have 9x minus 8x plus 1 equals 2. And then 9x minus 8x is x plus 1 equals 2. And 2x plus 1, x plus 1 equals 2. And we want to subtract 1 from both sides. That cancels. And of course, 2 minus 1 is 1. And so that will be our solution to that equation. All right, so moving on to number 17. For this one has a lot of fractions in it. And so if you don't want to deal with those fractions, the easy thing to do is to multiply both equations by both sides of the equation by the LCD. In this case, 16 is the LCD because we know that 16 times 1 is 16 and 8 times 2 is 16. And 16 is the smallest number that both 8 and 16 can divide into evenly without a remainder. So knowing that, what we're going to do here is we're going to multiply this side by 16 as well as multiply this side by 16. And of course, this is a variable x, not a multiplication symbol. Same here. So when we look at this, I don't know why I wrote a 2 there. So this should be 16 here. And so 16, same as 16 over 1. And of course, if I'm multiplying through, this would be 16 over 1 times 11 over 16, x, plus 16 over 1 times 7 over 8, which is the same as, well, equal to 5 divided by 8x times 16 over 1. And of course, this 16 and that 16, 16 divided by 16 is 1, so that reduces to 1. 1 times 11x is 11x. Over here, 16 divided by 8 is 2, so that means 8 goes into 16 2 times, 8 goes into 8 once. 2 times 7 is 14. 14 divided by 1 is 14. And then over here again, 16 divided by 8 is 2. So 8 goes into 16 2 times, 8 goes into 8 1 time. And you just have 5x times 2, which is the same as 10x. And so from there you see how we've basically eliminated or cleared out the fractions. Now to get our final answer, we just need to get x by itself. So here we can subtract 10x from both sides. That cancels to 0. 11 minus 10 is just 1x, and we can just write it as x. And then from here, if we subtract 14 from both sides, see that cancels, and what we get left is x on the left side and negative 14 on the right side. That would be your answer for that one. All right, so let's move on to the next set of questions. All right, so I forgot here I have one more type of linear equation that we have to solve for x for. And then after that, we'll move on to the equations where we'll actually have everything in formula form, where there is no numbers. And what we're doing there is just trying to solve for a variable. So again, in this situation, we see that we have a fraction, so we want to get rid of the fraction as fast as we can. So what I'm just going to do here is multiply both sides by 3, the same as 3 over 1. And when we do this, of course, 3 over 1 times 2 times 6 minus x over 3 equals negative 3x. And here these 3's reduce to 1 because 3 divided by 3 is 1. And I just have 2 times 6 minus x equals negative 3x. So now I'll go ahead and distribute. 2 times 6 is 12. 2 times the negative x is negative 2x. And that is equal to a negative 3x. Again, we want to get x by itself. So we need to add 2 to both sides so we can get x on one side. The negative 2x plus 2x cancels, and it just leaves us with 12. And negative 3x plus 2x gives us a minus x. Of course, to finish everything up, here I could divide both sides by negative 1. 12 divided by negative 1 is negative 12. Negative x divided by negative 1 is a positive x. And this is our answer. All right, so for the next set of questions, we're going to be taking formulas and solving those formulas for a particular variable. Okay. Now, in this problem, I could ask you to solve for L. For this one, I can ask you to solve for W. Either way, the process pretty much works the same. So here we need to get L by itself, so that means we need to get this term by itself. So since we know we need to get that term by itself, the one term that I know that I don't need on the right side is the 2w. So I'm going to subtract 2w from both sides. And that cancels. And this is just p minus 2w because these two terms are not like terms. And then that'll equal to 2 times L. Since we want L by itself and we got a 2 multiplied times that, we will divide by 2 to get rid of that 2. And so 2 divided by 2 is 1, so that reduces to 1 here. And 1 times L is L. And then, of course, here Just looks like P minus 2W, all that divided by 2. So this is an acceptable form of the answer. Some of you may want to go a step further, depending upon how you solve this, and want to break this into 2 separate fractions. If you do that, that is totally fine. But when you do this, just remember that here, these 2's reduce to 1, and you just have minus W here. So this is also an acceptable answer. All right, so let's move on to number 20. So number 20, this is the equation for accumulated amount for simple interest. And what we're trying to find out is R, or what your annual percentage rate would be. If you were investing some money over time and you were getting paid simple interest for it. So again, solving for R, we could do this several different ways. I think I'm going to take probably 2 approaches to this. So the first approach, since I need to get this term by itself because I need to get this R by itself, I know that this P I don't need, so I'm going to subtract P from both sides. When I do that, that cancels, and I just have A minus P, since both of these are unlike terms, and that is equal to P times R times T. Since R is the variable I need, I don't need the P and I don't need the T, and all these are multiplied times each other. To get rid of the P and the T, I can divide both sides by PT. And of course, if I do that, then of course, that reduces to 1, that reduces to 1, and all I have left is the R. So R is equal to A minus P over PT. Okay. So that's one way to do it. Now, for those of you, you may choose another way to do it. You may come up with a different answer. And I'm just going to continue this. Your answer may look something like this if you do it the other way. And of course, for here, you'll see that these P's will reduce to 1. So what you'll have is just A divided by PT minus 1 over T, which is equal to R. That is also an acceptable way to do this. Okay. Now, the only other way that I would know to do this is to factor out the P first and then deal with it that way. So for those of you that are interested in looking at it that way, I'm going to go ahead and do that next. All right, so if I wanted to rewrite this to where I factor out the P, then it would look like this to start off with. And then since this is P times all that, I could divide both sides by P. Now I have A divided by P is equal to 1 plus RT. Remember that we're trying to solve for R, so we need this term but don't need this one. So we could subtract both sides by 1. Again, A divided by P and minus 1 are unlike terms, so I could do, all that I can do is rewrite it like this. I have RT, and then here, to get R by itself, I would divide both sides by T, so that that could reduce to 1. So if I did that, that would look like this. And of course, if I was to simplify this a little more, it would look like the other example I was talking about, which was A over PT minus 1 over T is equal to R. Okay? It would look like that as well. But if you leave it this way, I'm okay with you leaving it that way. If you left it this way, I'm okay with that. And if you did it the very first way that I did it, that is okay as well. All right, so let's move on to number 21. All right, so for number 21, we need to solve this for b, which is this variable here. So we're going to have to sort of work our way inside of this. Again, there are several ways to do it. I'm going to take the approach that I think is easiest to get there. So the first thing I'm going to do is, since I have this fraction here, I'm going to multiply both sides of my equation by 2 so that I can get rid of this fraction as soon as possible. So if I do that, 2 times a is just 2a, 2 times 1/2 is just 1, and 1 times b, big B plus little b is just big B plus little b. And I forgot the h there, yeah. So let me write this over again because I forgot the h. So let me just start over. All right, so I want to multiply both sides by 2, and that's going to be 1/2 times h times big B plus little b, like that. And again, 2 times big A is 2a, 2 times 1/2 is 1, times h times big B plus little b. And of course here, 1 times anything is just that anything. And now we're at this point. Now that we got rid of the fraction, now we can take our h and distribute it across here because it's easier for us to do. So this will be h times big B plus h times little b times 2a. And then we just need to solve to get this particular term by itself. So to do that, hb has to be subtracted from both sides. That cancels. And these are unlike terms, so that's just 2a minus hb. And to get b by itself, I would have to divide both sides by h. And those h's would reduce to 1. And what I would have is 2a minus hb all over h, which is equal to b. And so this is what I think the easiest way to get this result. All right, so for number 22, what this is the equation that we use to translate Celsius, temperatures in Celsius to Fahrenheit. And what we want to do is rearrange this equation to solve for C, which actually means Celsius in this case. So for here, kind of put a line through this. So for here, we want to get C by itself. So the first thing that I see is that if I wanted to do that, I could subtract 32 from both sides, okay? Some of you may be thinking, well, why don't you get rid of the fraction first? I could do that, and I'm going to do that in the second attempt of this example here. So this 32 minus 32 cancels to 0. I have f minus 32, which is equal to 9 over 5 times c. And of course here, what I could do to get c by itself, since I have 9 divided by 5, I could divide both sides by 9 over 5, but that's the same as multiplying both sides by the reciprocal of 9 over 5, which is just 5 over 9. So here, we're going to multiply both sides by 5 over 9. And so if I did this 5 and that 5 reduces to 1, that 9 and that 9 reduces to 1, and all I have left is 1 times c, which is c. And then over here, of course, I have the 5, 9 over this. And if you kept it like that, that is acceptable. Okay. For those of you that want to go a little further, you may want to interpret this as this over 1 and distribute your 5 across here. And if you did that, that'll be 5f minus 160 divided by 9 equals C. And that is perfectly acceptable as well. Okay. So for this one, either we go with this answer here, or we go with this answer here. Both I will accept. Okay. All right, so now what I'm going to do is erase this and go through this the alternative way that I was thinking about. All right, so the alternative way I was thinking about doing this is just starting right from the beginning, trying to clear out this fraction here. And of course, since the denominator is 5, and that's the only denominator, then that's what the LCD is. So we'll multiply both numerator and denominator, sorry, not numerator and denominator, but both sides of the equation by 5. So we have 5 times f is just 5f. And of course, here we're going to take 5 and distribute it across. So if we do that, and of course, 5 times 9 over 5, these 5s will reduce to 1, and all I'm going to have is 9c left. And of course, 5 times 32 is 160. So if we rewrite everything, this is 9c plus 160. And then from here, we need to solve for c. So now what I can do is subtract 160 from both sides. That's 5f minus 160 equals to 9c. And then you can see from here, if I divide both sides by 9, then I'm going to end up with the same thing I had before. That's this, and then it reduces to 1. All right, so let's go to our last set of problems to close us out. All right, so for our last 2 problems, we're dealing with word problems here. And this is to test some of the things that we learned in week 1, which is how do we translate a sentence into a mathematical statement. And so this is one of those examples, and we're going to use that plus solving linear equations to be able to answer this problem. So for here, it says the code to unlock a safety deposit box is 3 consecutive odd integers. Key phrase there, consecutive odd integers whose sum is 87. We want to find out what these integers are. So first thing that we know is we have 3 integers, okay? So here, well, first of all, we need to talk about what an integer is. So integers are numbers like -3, -2, -1, 0, 1, 2, 3, so on and so forth, in both directions here, okay? And we want 3 consecutive odd integers, okay? So odd meaning numbers like 1, 3, 5, 9, 7, whatever. And so we know that since they're odd, the difference in between any 2 odd numbers is 2. So if we let x be our first integer, whatever it is, then of course we know that x plus 2 is going to be the second integer, because there's a difference of 2 in between each odd integer. And then, of course, if we add 2 more to this one, that'll be x plus 4. That will be our third odd integer. And I should put here that they're odd. And so now we know that the first integer plus the second integer plus the third integer have to all add up to be 87. And so now at this point, we just solve for x. So we have 1, 2, 3 x's that are being added, so that'll just be 3x. And then we have 2 plus 4, which is 6. and then that equals 87. To solve for x, we subtract both sides by 6. Those 6's cancel, and we have 3x is equal to 81. And now we just divide both sides by 3. Okay. And if we do this, then of course 3 goes into 8 2 times with the 2 remainder, and 3 goes into 21 7 times with a 0 remainder. So we know that the first integer is going to be 27. So that means the second one is going to be 29, and the third one is going to be 31. Okay. And so to close this out, we would just say that the code to unlock the safety deposit box is 27, 29, 31. Okay. All right, so for our last problem sort of deals with some of the things that we deal with in this section, but I'm also using it as a segue to get to our next unit, which is in week 3, which is solving systems of linear equations. So, one other thing. Before I go to this problem, let me jump back to number 23 for just a second. So, do you see how here they talked about this 3 consecutive odd integers? If I change this problem, instead of me saying 3 consecutive odd integers, if I would have just said 3 consecutive integers, this problem would have changed. And it would have changed because now integers just normally, not saying that they're odd or even, they only have a difference of 1 in between them. So if I was going to define these variables with this case, then of course x would be the first integer, x plus 1 would be the second integer, and x plus 2 would be the third integer. And what I would have to do then is take x, x plus 1, x plus 2, and add all that up and make it equal to 87, and then solve for x that way. And so my point here is watch the wording on these problems. Do not get in autopilot and just say, hey, I saw one on a review like this, so it's going to be the exact way. Okay. Some of them may say consecutive odd integers. Some may say consecutive even integers. Some may say just consecutive integers. Okay. So you got to watch what it says. All right, so now let's jump to number 24. Sorry about that. I didn't want to forget that. So we know that for this one, on a buying trip in Los Angeles, we had Rosario Perez. They ordered 100 pieces of jewelry, a number of bracelets at $8 and a number of necklaces at $11. And she wrote a check for $1,200 to pay the order. How many bracelets and how many necklaces did Rosario purchase? Okay. So here, notice we got 2 pieces of information here. So we have a jewelry equation. We could also call this a materials equation. And we have a cost equation. Okay. So here we know that Rosario ordered 120 pieces of jewelry. Okay. And so we want to know how many bracelets, how many necklaces. If we let X be the number of bracelets and Y be the number of necklaces, and I'll go ahead and define my variable here, number of bracelets, Y is going to be the number of necklaces, then what we know is that all the bracelets plus all the necklaces has to end up being 120. So X plus Y has to be 120. The next piece of information, we know that each bracelet was $8, each necklace was $11. And we know that the total that Rosario paid was $1,200. So we got $11 times the number of necklaces that we have. Oops, let me do that the other way. Yeah. So here, the necklaces is Y, not X. So let me make sure I get that together. So here we know that a number of bracelets at $8 each. So that's bracelets here. $8 times the number of bracelets plus $11 times the number of necklaces, and that's going to have total payout of $1,200. And so now what we want to do is find out basically what X and Y are. Now to do this, we're going to learn two different methods in week 3, but for right now I'm going to take a simple approach and use what we call the substitution method. And so here, all I have to know is this. So I have two equations, two unknowns. I know that I can solve this equation. What I'm going to do is I'm going to rearrange this equation, and I'm going to write X in terms of Y. And so how I'm going to do that is I'm going to subtract Y from both sides here. And if I do that, that's going to cancel to 0, and I'm just going to have X equals 120 minus Y. And so now that I know what X is in terms of Y, I'm going to take this and I'm going to plug it in where X is. So therefore, I have 8 times X, but instead of X, I'm going to write 120 minus Y in parentheses plus 11Y, which is equal to 1,200. And so now from here, I'm just going to solve for Y. I'm going to distribute my 8 to both terms there. So if I go ahead and multiply 8 times 120, that should be 960 minus 8Y plus 11Y equals 1,200. Combining like terms, negative 8Y plus 11Y is a positive 3Y, which is equal to 1,200. And then of course here we can subtract both sides by 960. And that cancels. Here this will give me 3Y on this side. And on this side, 1,200 minus 960. That looks like that would be 240. And then from there, we just divide both sides by 3. That reduces to 1. And 240 divided by 3 is just 80. So this is the number of necklaces Yep, so let's try to write that again here. Yep, so that would be the number of necklaces. And of course, we have a total of 120 necklaces. So of course, to find the number of bracelets would just be 120 minus 80, which would be 40. And that will be the number of bracelets. Okay. So at the end of the day, we know that Rosaria bought 40 bracelets and 80 necklaces. All right, and so this concludes the review for quiz 2. I hope this gives you a good idea of what it is I am expecting you to be able to do on your quiz for week 3. Again, please take the time to look over this. You will be given the link to this, but this should be shown in class, but if not, you'll be able to see it at home. In addition to that, every question that's on here in some shape, form, or fashion is going to be on some version of the quiz, so you kind of know what to expect. It's just a matter of making sure that you study and get familiar with the problem so that you ace it whenever it's time to take the quiz. So again, thank you so much for paying attention, and hope this helps. Take care.